This is June 2023. Paper is 42 and the threshold was a bit high, 30 out of 40. It's a high threshold. And a student measures the capacity of a drinks cup by three different methods. The capacity of a cup is the maximum volume of liquid that it can hold. Method one, the student measures the height edge of the cup, the diameter d of the top of the cup, the diameter small d of the bottom of the cup. The figure shows a full size diagram. Full size means that you can put a ruler, but in your printout or in your past paper books, normally the size is not exactly the same. So marking scheme answers normally vary here. So figure a full size diagram of the cup, measure the height, the diameter. So you have the printout. So please put the ruler. So if you have a ruler, place it and let me know capital D, small h.
The H is 7.8.
7.8. Okay.
And capital D is 6.6. And the small D is 4.4.
Sorry, 4.4. Measures the height h, the diameter d, and the diameter d of the cup. So we have mentioned our values. Calculate the average diameter dA of the cup using your readings. 6.6 plus 4.4.
5.5.
5.5. Calculate the value for the capacity of the cup using the equation. Can you please check the marking scheme if you have it? What are the marking scheme values of H, D, and D?
Oh, I don't think I have the markings.
Can let it go. We can check it later. Because have you double checked these values? 7.8, 6.6.
Yeah.
Okay, good. So you have this value here now.
I think the capital D is 6.5.
Doesn't matter. A slight difference is fine. Now we have gone through it. No problem. Now in the paper, this type of question is expected also, where you have to measure it. So you have to read it double because multiple calculations are ahead. So read it double check it, and
I'm getting 185.31.
185.3. Method number 2, the student uses a length of a string and a meter rule to determine the average circumference of the cup. He must be planning to wrap the cup by the string, wrap it around, and after making a circle on that, that student must be thinking to find the circumference. The student wraps some of the string 5 times around the cup. Measure the length of the string. He measures the length of the string. Use 87.5. He says 5 times. So these are the 5 circles. So if he has measured it 5 times, if there are 5 times he moved the circle, then what would be the circumference, round of one circle?
88.
I should divide it by 5 because this is the length of 5 circles and I want to know the length of one circle. So I have to divide it by 5.
$17.58.
17.5. And what is after that?
58.
He says use your answer of H from A1 and C from B1 to calculate a value for the capacity. So you have C square. H is 7.8.
Third.
Let me know what answer you are getting.
$191.83.
191
83.
right. The student fills a measuring cylinder with water up to 220 cm cube mark. The pours water from the measuring cylinder into the cup until the cup is full. Records the new reading R on the measuring cylinder. Write down the new reading. It should be 20 and then 30. Should it be 32? Because two divisions, one division is looking to be for 2. Read the scale.
Mm.
So can you read for me? This is 20 and the center will be 32. So this number is, the center is 30 and then it is
Is it
30.
not? I think it's 31.
If you make it 31, start moving up. This is a good way to understand, Zainab, this point, that if it is 31, how you will reach 40? Steps up. If it is 31, then this will be 32, then this will be 33, then this will be 34, then how you will reach 40? Actually, this is to know that the division size
So we're
varies.
taking 2 divisions. Okay.
It means that one division is for 2. Just count.
Okay.
If I take it 32, step up and reach 40. Look, if you reach 40, if you take this by 2. So in the paper, whenever you have a confusion that it is 1 or 2, use this method which I'm telling you. This will be 34, this will be 36, this will be 38. Determine the volume of water in the cup. Show your working. Determine the volume of the cup. And do we have any formula?
Mm.
Where is the cup?
They have given us the volume 220, so we subtracted from 32.
Where?
220 minus 32.
Fills the measuring cylinder with water up to 220, pours water from the measuring cylinder into the cup until the cup is full. Okay, right, very good. So it means it was originally 220.
Yes. Now it's 188. Oh, the value of R you have written 38 in the above part. It's
Oh, sorry,
32.
it's 32.
Yes, and the volume would be 188.
Yes. All three methods of determining the capacity of the drink cup give values which are approximate. State one reason why the volume calculated in method 2 and one reason why the volume calculated in method 2 and one reason why the volume calculated in method 3 are not accurate. method 2 and method 3. First, see what was method 2. Let's go back and see what was method 2.
Okay.
This method means that he's wrapping a string around the cup, just like many people measure their own waist by using an inch tape and wrapping it around the waist, and they measure it, and he wrap it 5 times around the cup. So he says there is an error in this method. Reading the question and then answering a relevant thing is very impressive. So if this is the cup, what he is doing, he is wrapping the like this 1, 2, 3, 4, 5 like this. So maybe the
I think
string
the string will be too tight if it's wrapped like that.
very good. Maybe the string is over tight. Maybe the string overlaps. Maybe the string is loose. So if you measure this way, maybe the string comes on each other. So when a round of a string comes on the previous round, it will be an overestimation. The length will be overestimated. So this is a source of error. So you can write any one of them. Method 3. The student fills a measuring cylinder with water up to the 220 cm cube mark. Pours water from the measuring cylinder into the cup until the cup is full. Maybe in this method, when you are transferring liquid from the cylinder to the cup, some water spills. This is a common thing. When you transfer a liquid from one to other,
or water may be left in the measuring cylinder.
Right. Maybe the cup is not perfectly full. So there are many possible things here. A student investigates the effective resistance of different combinations of resistors and lamps in circuits. The student set up the circuit shown. Look at the circuit.
I've measured the
student closes the switch, measure the PD across the resistors and the current I1 in the circuit, opens the switch. The reading on the voltmeter and ammeter are shown.
It's 2.9 on voltmeter.
Voltmeter is 2.9, right?
And the current is 0.46.
Current is 0. But you have to be careful, it's 0.4, 0.5, 0.45, 0.46.
0.46.
Huh? It's coming 0.46.
Yes. $6.30.
Yes, 6.30. Suggest why the switch is opened after the readings of potential difference and current have been taken.
To save the power or prevent overheating.
Because to save the power is fine, and overheating is also good, because switch open means you are turning it off.
Yes.
The student rearranges the circuit that the resistors are connected as shown, closes the switch, measures the PD and the current. Now the resistors are in parallel. Solve this.
3.18. 3.18.
Sorry.
3.18.
Okay, double it.
$10.11.
10.11. 10.18.
10.11.
10 point. What you are saying? 10 point.
10.11.
10.11. Are you doubling it? Because it should be 2 into 2, 8 are 16, 3. Can you double check 3.18 into 2? Double check the multiplication.
It's 6.36.
Sorry,
It's 6.36.
6.36. For what? R2 or 2R2?
2R2, 3.1 and multiply by 2.
Okay. So what is the corrected answer? 6 point.
36.
That looks fine. If the resistors are identical, theory suggests that R1 should be equal to 2R2. Two quantities can be considered to be equal within the limits of experimental error if their values are within 10% of each other. This is called tolerance level. State whether the results indicate that the resistors are identical. Support your statement with a calculation. What was our R1? R1 was 6.30. Solve this. I'm just coming. Solve this. How much is the percentage coming?
0.95.
0.95. Are you sure? Have you subtracted the numerator? Can you subtract the numerator again?
Okay. It's 0.95.
How come 6.36 minus 6.30? Can you
Yes,
sub
it's
0.95? I don't understand. How can you try to type the numbers carefully? 6.36 minus 6.30
I got 0.06 and then I divided by 6.3.
divided by 6.3.
It's 0.52.
I'm not getting again how it can be 0.5. Please divide again. 0.06 divided by 6.3 into 100.
It's the same answer, 0.5. 0.95.
Now if the answer is confirmed, 0.95, it is much less than 10%. 0.95% is less than 10%. He has given a threshold of 10%. So it is within the tolerance level. The resistors are identical. The student repeats the experiment in A and B, but replaces the resistor with lamps. He obtains the following result. The effective resistance of the combination of lamps connected in figure 2.1 is 5.2. The effective resistance R3 of the combination of lamps is 2.4. He says that he has attached He has attached lamps now in place of resistors. Lamps have a property that when they are switched on, their temperature increases and their resistance also increases. The teacher explains that the resistance of the lamp filaments changes due to a heating effect, and therefore R3 is not equal to 2R4. One observation that the student makes while during the experiment that support the teacher's explanation. So you have to read this part carefully when you are attending a real ATP. Remember this concept that ATP papers are general papers. So you have to read the question at least 2 times. So because the answer is always within the question. Lamps always are heating effect problem. Lamps always face heating effect problem. So when you attach lamps here instead of resistors, lamps will get heated.
The lamp gets hot.
Lamps get hot. This is right, and they're over bright and
Brightness of the lamp changes.
they're not of the same brightness. The student extends the investigation using a different combination of the 3 lamps to the 2 combinations already used in A and B. Now he has made another combination. Complete the circuit to show a third way of connecting 3 lamps. Look at the first one. When you started this big long question, the 3 lamps made, 2 lamps were in series and 1 was in parallel. When in the second combination, all of them were in parallel. So obviously there are many other combinations possible. Just remember, do not make the circuit which is already used. So I can do one thing. I can attach.
Sorry, I couldn't hear you. What did you say?
I can attach 1 lamp in series. Can you hear me now?
Yes.
Look at this option.
Okay. Done.
A student investigates the image formed by a converging lens. The student arranges the apparatus as shown. The illuminated triangular object is shown full size in figure 3.2. The lens is there is a screen, and the distance U. Measure and record the height of the triangular object. So you put the ruler.
2.5.
Sorry?
2.5.
Right. Then proceed forward. The student
The next
switches
part
on
is
the lamp and places the lens a distance u20 from the triangular object. Adjust the position of the screen until a sharp focus image of the triangle object is formed. It's a full size again. Now measure this.
7.4.
Sorry,
7.4.
7 point.
4. 0.13.
0 point
13. 0.13.
13.
Yes.
Okay, then 1 upon 3.9. 7.4. What did you told me here? 1 upon h, 1 upon 7.4 is 0.13.
Yes.
Okay.
And this one.
Let's keep on double checking the answers. What about the 1 upon 3, 1 upon 3.9?
0.25.
Okay.
0.38.
0.38.
Next one. 0.625. Last one. 0.90.
0.90.
90.
The screen is a square sheet of white card of side 10 centimeter. Look at the data in figure 3.1. Suggest why the student does not use values of u when which are less than 20. It's a square sheet of white card of side 10. The student didn't cross, didn't go under 20. Maybe the 1 upon h 7.4 is there. Already we have reached 7.4. Look at this number and this number. So compare these two numbers and tell me why he didn't go below 10. So if I take u less than 10,
I think the image would be too big to fit in the screen.
The h will, at the h may, if I take u less than 20, the h can exceed 10. On the grid provided, plot a graph of 1 upon h on y-axis and u on x-axis. and u on x-axis. Okay. He says start both axes from the origin. Start both axes from the origin and line of best fit. He is not using the word straight line. So maybe, actually, he's using the word straight line. Sorry. He's using the word straight line, which means it should be a best fit line. Now look at this screen. And I have to plot 1 upon h on y-axis. Look at the biggest number. The biggest number is 0.9. The largest number is 0.9. So I can put 0.2, 0.4, 0.6, and u is going till 50. The first is 20 against 0.13. Point 1. Then it is 25 and 0.25. 1 on y-axis, one small division is 0.02. On y-axis, one small division is 0.02 because 5 divisions are 0.1. If you look here, now, there are 5 divisions going for 0.1. So if I take one division, it is 0.02. This is a very important thing in the paper because if you rate it perfectly, then you can plot it correctly. 30 and 0.38. 30 and where is 0.3? This is 0.3. 32, 34, 36, and 38. Then on 40.625, 0.6, 0.62, and slightly above that.